This is lesson 405, Isosceles Triangles, part 1. The objectives we're going to be covering in this lesson are to identify, how about it says identity, but identify the parts of an isosceles triangle and use CPC-TC to prove congruence of corresponding parts. And you may be asking, just what do those letters mean? And I will be glad to share it with you. The key terms that we'll be going over in this lesson are base of an isosceles triangle, the base angles, and looky there, CPC, TC. It means abbreviation for corresponding parts of congruent triangles are congruent. So, corresponding parts of congruent triangles are congruent. Alright, so that's what it means. And you definitely want to remember those letters because you don't want to have to write out that whole statement. The next is legs of an isosceles triangle and the vertex angle. So for CPC-TC, it says the polygon congruence postulate states that if two triangles are congruent, then their corresponding parts are congruent. And another way to say it is corresponding parts, of course, of congruent triangles are congruent. Blah. Because it's such a long statement and our tongue gets tied saying it, we like to use CPC-TC. So for example, if you look at this triangle, picture of these triangles right down here, you see that angle A, well, you don't know for sure, but I'm telling you, I know it's true. Angle A is congruent with angle D. Angle C is going to be congruent with angle F, and angle B, let me draw 3 of these, is going to be congruent with angle E. Also, if you notice, AC is corresponding with DF. CB, oh, let me draw a square there, is corresponding with FE. And then we've got AB is corresponding with DE. So all of those would be corresponding parts of congruent triangles are congruent. On to an isosceles triangle. It says an isosceles triangle is a triangle with at least 2 congruent sides. So an equilateral triangle, I wonder what color, okay, equilateral triangle could also be considered an isosceles, okay? But usually when we have a triangle that has 3 sides congruent, like this, we just go ahead and call it an equilateral. We don't call it an isosceles. But whenever we do say isosceles, you know there is at least 2 sides that are congruent. Alright, the 2 congruent sides are called legs. So these 2 congruent sides are marked here, and you can see that I've labeled each one leg. So those, whenever we talk about isosceles triangle legs, we're talking about the congruent sides. The angles opposite the legs are referred to as the base angles of the isosceles triangle. And what I want you to note in this drawing is that those base angles are congruent. Notice they're opposite congruent sides and they are congruent. The base of an isosceles triangle is the side included between the 2 base angles, and you can see it highlighted in red and the word base above it. And then the vertex angle is the angle opposite the base, always. So let's look at some examples. It looks like when I transferred these slides, they moved my pictures a little bit. That wasn't very nice. This says, explain how you would use side, 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 or angle, side, angle with corresponding parts of congruent triangles are congruent, CPC-TC, to prove that each statement is true. So when they say each statement, they're talking about different problems. We're just wanting to prove right now that angle K is congruent to angle P. So if you notice, that's not marked in this picture. What we do notice is that they've marked angle J congruent to angle N. We know that L and M are congruent because they're right angles. And if you look right here, they're saying that JL is congruent to MN. So right there, we know that triangle KLJ, let's look here, triangle KLJ is congruent to triangle PMN because of ASA, angle side angle. Alright, so that means that angle K has to be congruent to angle P. Let me see if I can quit writing upwards. By CPC TC. Okay, because we know the triangles are congruent, so that means their corresponding parts are going to be congruent. And we can go ahead and put 3 little marks there. Okay, so that's how we know angle K is congruent to angle P. Alright, this one we're trying to prove that segment FG is congruent to segment DG. So let's look. We can tell right here that angle, I'm looking at the FEG, is going to be congruent to angle DEG because it's marked there for us. And we know that FE is going to be congruent to DE because they've got those little marks for us. And get this, we know that EG is congruent to EG, and we know that because of the reflexive property. It's congruent to itself. So because of this and the other information that was given to us in the triangle or in the triangles, we know that triangle DEG is congruent to triangle FEG, making sure I'm writing the letters correctly, FEG by side angle side. Okay, now I didn't write them in the order up here, but if you look, you've got side, and then you've got the angle, and then you have side. So side angle side. Oh, here's a side over here too. Okay, so therefore, since we know those triangles are congruent, FG is going to be congruent to DG by corresponding parts of corresponding triangles, or of congruent triangles, are congruent. Okay, so that means these guys up here have to be congruent to each other. And these guys over here, they have to be congruent to each other. Okay, this example says, given that triangle QNM is congruent to triangle RNP by side angle side, and you can see that we've got a side, an angle, and a side. Okay, it says determine if each statement is true according to the CPCTC. And remember, that's corresponding parts of congruent triangles are congruent. So we're going to look at part A, and we're going to say, is MN congruent to NR? So MN, NR. Oh, we're going to say no because they are not corresponding. I'll abbreviate that. That's part A. So the way you would write that, just so you know, and then you would take and put a line through that. They're not congruent. B says, is QN congruent to NP? So I'm going to come over here and I'm going to look. Let me see. QN goes right here. And is it congruent to NP? And there again, you're going to say no, because they're not corresponding parts. And C says, is QM congruent to PR? So let's look. QM is right here. I'm going to put 3 marks on it. To PR. Yep, yes it is. Because they are corresponding. That's bad corresponding. They are corresponding parts. CPC, TC. There we go. Alright, it says triangle ABC is isosceles. Which sides are the legs? Okay, if you look, they're telling us that AC is congruent to BC because they both measure 42. So we know that AB down here, AB is going to be our base, segment AB, and we know that our legs are AC and BC. So these are the legs. This is the base down here. And it says, what is the name for angle A? And you're thinking, what is the name for angle A? Isn't it angle A? Remember way back when we learned, not way back when, sorry, that the name of this angle and this angle right over here, those are called base angles. So you can even write on there base angle, and then over here we can write base angle. And then what is the name for angle C? That is going to be your vertex angle. Oops. So I'm going to write up here vertex angle. Just a summary for this lesson, we learned that CPCTC stands for corresponding parts of congruent triangles are congruent. We also learned that an isosceles triangle is a triangle with at least 2 congruent sides. After you get finished watching this video, please go through and read the LMS lesson 405 Isosceles Triangles. There is a little bit more information in there than I gave you in this lesson. And then complete the student guide. Be sure to read pages 111 through 115 in the reference guide. And then complete the following problems in the problem set, which is 1 through 11 odd. And be sure after you get finished with the problem set, contact me or attend TOGA if you have any questions before you complete the 405 quiz. That's going to be it for this lesson on isosceles triangles. Thanks for listening.